Huffman coding. So these are the elements and these are the frequencies of these elements. So how we make it compressed with the help of Huffman coding, as we see in the last lecture, that Huffman coding basically used for compressing the data. So we start with the lower. Whatever is having lower frequency, we take this first. So first we make E and F. E, F, 2, 3. So which make it 5. Now what is next? This is over, 5. 5 is less. So we will take 5 and 5. This is also 5 and this belongs to B. So we write like this. This is B and its frequency is 5. So this and this will make it 10. Now what is next? 15. What is next? 15. So 10 is there, so 15 belongs to C. So we'll write here C. 15 of frequency C. This is also over. So 10 and 15, what will make it? It will make it 25. Now what is left? What is minimum now? 30. So we will make 30. So 25, 30. 30 belongs to D. So we will write here D. 30 is its frequency. So what it will be? It will be 55. It will be 55. Now what is left? 45, which belongs to A. So we will write here like this. A. This is 45. So we will make it. So it will become 100. It will become 100. So now our tree is ready. So now we will do coding. Coding means on the left hand side we take 0 bit, we suppose, and right hand side we suppose 1. Left hand side we suppose 0, right hand side we suppose 1. Left hand side we suppose 0, right hand side we suppose 1. Left hand side we suppose 0, right hand side we suppose 1. Left hand side we suppose 0, right hand side we suppose 1. In that way. So as we have seen, or we can say like this also, smaller we put left and greater we put right. Smaller side we put left, greater, and right hand side we put greater. Smaller and greater, like this we will add the tree, and we will put the bits like 0 on left hand side and 1 at right hand side. So now we will see for A, what is the coding after compression. We make Huffman coding tree like this, starting from lower to higher, and now we'll see according to the bits which we have defined here, what are the number of bits belongs to A. A, only one bit, that is 0, and the number of frequencies are 45. Number of frequency of A are 45. So we can say how many number of frequencies. If we are having more number of having a frequency, then we will introduce a bit less number of bits, that is 1 bit. Now we'll see for B. B, what it will be? It will be 1001, 1001, 1001. Now for C, we'll see. For C, what we will have? We have, sorry, for B we'll see from here 1001. For A 0, for B 1001. For C will be 101, 101. For D, what it will be? It will be 1 1. For E, what it will be? It will be 10000, 10000, 10000. And for F, what it will be? It will be 10001, 10001. So we can say simply, or we can see by this Huffman coding, where number of frequencies are more, the number of bits representation is less, and where number of frequencies are less, like E and F, the number of bit representation is more. So if we add all these so 45, if we add like this, suppose 45 into 1, now according to the number of frequencies. So 45, how many bits are there? 1. And number of frequencies 45. B number of frequency is 5, and number of bits are 4. And C number of frequency is 15, and number of bits are 3. D number of frequency is 30, number of bits are 2. E number of frequency is 2, and number of bits are 1, 2, 3, 5. F number of frequencies are 3, and number of bits are 5. So if we multiply and add them, then it will be 195 bits. It will be 195 bits. So what we can say simply, it's application of its application is greedy. Its application is greedy, so no one can do less than this. I mean, say that we can not reduce more than these bits. So but if we go less than that, then what will happen? Data will get damaged. And 100 characters, as we have seen here, how many characters? Total 100 characters. So 100 characters equal to how many bits? 195 bits, as we have calculated. So we can say one character, then how it will be? 195 by 100, that is 1.95, that is 2 bits per character, 2 bits per character, with the help of Huffman coding. Or we have seen here also, what we have seen? Higher frequency will be at near root, and less frequency will be at leaf node. So higher frequency is near root, so easy access, and a lower frequency which is required less, so it is nearby leaf node. So this is the way how we can design the Huffman coding and how we can reduce the number of bits according to the number of usage of the character.